Okay, welcome to this next video, guys. Today we're going to be talking about solving equations. So this is probably the first time where you're probably going to start to use these algebra tools to actually start to do something to solve some problems with, okay? Up till now, you've just been learning how to use the individual pieces, but now you're going to start to sort of put it all together and come up with some solutions. So the learning goal is that students interpret and solve linear representations and model some authentic information. And at the end of this, you'll want to be able to analyze a simple linear equation and solve a given simple linear equation. Okay, the first thing I want you to know is that equations are like onions. All right, now, it's a bit of a quote stolen probably from Shrek, but you'll see what I mean by that. Okay, now remember we had expressions which were things like 2x plus 4. Okay, so that's an expression. It's just a set of terms added or subtracted from each other. But an equation adds in this extra thing equals 3. So now this is an equation because this side, which is called the left-hand side, okay, and this one, which is the right-hand side, okay, they have to be equivalent. That's what the equation thing kind of means, all right? And it also means in this instance, x actually has a number. Okay, it actually has a value that we can find in these equations. Okay, that's a big change from where we've been with expressions, all right, where the variables didn't have to have a value necessarily. Okay, now when we're talking about equations being like onions, what that means is that if we want to find what this x is, we can't get to it yet, okay? There's things that we have to do operation-wise to arrive there. And what happens is that this x was sort of sitting there, then this 2 just rocked up out of nowhere and decided to multiply the x, right? Then, when it wasn't looking, the 2x had 4 added onto it. So if you can kind of see, there are different layers to this left-hand side of the equation. Okay, we're going to see what that means later in a bit about how we unpack that to try and solve our equations. All right, a couple of key ideas. So to solve an equation, what we end up doing is we create a series of simpler equations by operating on both sides of the equation. Okay, now it's very important that you must perform exactly the same operation on both sides of the equation. All right, now you can do whatever you want to both sides of the equation, just have to make sure that you do exactly the same thing to both sides. Okay, so for example, if we had 7x plus 5 equals 20, you would be allowed to go, I'm going to subtract 5 from this side, and I'm also going to subtract 5 from this side, and you would have left over 7x equals 15. Okay, totally okay to do. If for some silly reason you're sitting there and saying, you know what, I'm going to multiply both these sides by 2. Now, it wouldn't help you solve it at all, but it is something that you are allowed to do. So you'd have 14x equals 30 now, and that's totally okay for you to do. All right, so it's very important that you know that you can do whatever operation you want as long as you do the same one to both sides of the equation. Okay, right, now you should strategize first though how you will solve the equation before you start. Okay, so like I say, make an onion out of it and then peel the layers off and you'll be left over with your x. Okay, so let's draw up ourselves another little example. So if I had 3x minus 7 equals 23, okay, first thing we do is we circle the variable that we're trying to solve for, okay, then you go about sort of going, okay, what's happening to the x next? The 3 is acting on the x next. Draw a layer. Then the next thing's happening is they subtract 7. So there's our layers there around the equation. So you know that when you are operating on this equation, you're going to have to remove these layers to get to the x, okay? The x is where we want to get to. I'm going to have to get through all these layers to get there, all right? Break through them. So the first one we have to break through is this subtract 7, and so you do the opposite of that. So it means that you'd have to add 7 to both sides to get there. This 3 then is multiplying onto the x. So to get rid of that layer, you have to undo it, which means you have to divide by 3 to both sides, okay? Now, in the end, you can check your solution by substituting back into the original equation. So get your original equation, get the left-hand side or wherever your variables are, substitute your solution back in, and you should get the answer out that you had at the start. And then that means that you're correct. Okay? All right, let's have a look at some of these examples. So we're going to solve the following equations. So we've got x plus 5 equals 8. Give myself a bit more room. So let's write that out here for ourselves. X plus 5 equals 8. Okay, let's lay this off. So there's the x. The next thing that's happening to it is adding 5. Okay, so that means I gotta get rid of this add 5. So I'm going to do the opposite, which is to subtract 5 from both sides. Okay, 5 minus 5 is 0. So I'm left with x is equal to 8 minus 5 is 3. Okay. That was a reasonably simple one, but it's always good to start in some easy stuff. Okay, so a little bit more difficult this time. So let's write our equation for ourselves. So 3x minus 4 equals 20. Okay, so let's onion this. So you're going to circle the x. The 3 is acting on it next. Then there is a subtract 4 over here. And so that means to get through these layers, the first layer is then subtract 4, then to get through the next layer will be the 3 times. So we're going to do opposite. First thing we're going to do is add 4 to both sides. And our next line will be then 3x equals 24. Okay. Now you can re-onion this or just remember that, okay, that next layer here was this 3 times x. So the opposite of that, 3 times x, is to divide by 3. Divide by 3, and so 3x divided by 3 is x. 24 divided by 3 is 8. Okay, so x would be 8 in that situation. Alright, our last one to have a look at for this one here. So 7x plus 3 is equal to 17. So let's rewrite that for ourselves. 7x plus 3 equals 17. Onion it off. There's our x. The next layer is a 7. Plus 3 is our layer here. Okay, so that means our first step is going to be the opposite of plus 3, which is to subtract 3 from both sides. And we're left with 7x is equal to 17 minus 3 is 14. The next layer was this 7, and it's multiplying the x, so that means we're going to be dividing by 7 to both sides. Okay, 7 divided by 7 is 1, so we're left with x. 14 divided by 7 is 2. Okay, there you have it. Now, with this algebra stuff, it is very important that when you're solving these equations that you go about strategizing what you want to do first, so that you don't sort of get lost in the initial looking at the equation. And I want you to work down the page as I've demonstrated in this video, and I want you to show with the arrows on the sides the operations that you're carrying out as you work through. It is very important that you take the time to show your algebra working as I've shown you in this video, so that you can learn the basics and learn them very well. You don't want to learn any tricks or shortcuts now and then have to deal with that later on when things do get a little bit harder with your algebra. Okay? Thank you so much for watching, and I'll see you at school.